Few crypto projects have been as widely misunderstood as Internet Computer. Launched with extraordinary expectations and followed by a sharp market repricing, ICP quickly became associated with excess, complexity, and disappointment in the public narrative. Yet beneath that perception sits one of the most technically ambitious blockchain projects ever attempted. By January 2026, Internet Computer remains controversial, but it also remains fundamentally different from nearly every other network in crypto. Welcome to the Crypto IQ. Today we're breaking down what Internet Computer is actually trying to build. We'll examine its architecture, real-world usage, developer traction, and long-term vision to understand whether ICP is a speculative relic of the last cycle, or whether it represents one of the most asymmetric infrastructure bets heading into the next phase of Web3. Internet Computer was designed to extend the public internet itself. Unlike traditional blockchains that focus primarily on token transfers or smart contracts, ICP aims to host full applications, websites, and services directly on-chain. The goal is to eliminate reliance on centralized cloud providers such as AWS, Google Cloud, or Azure. In practical terms, this means applications on ICP can serve web content, store data, and execute logic entirely on decentralized infrastructure. Users interact with these applications through standard web browsers without plugins or centralized servers acting as intermediaries. This vision places ICP closer to a decentralized cloud platform than a conventional blockchain. Internet Computer uses a unique architecture built around canisters, which are upgraded smart contracts capable of storing data, serving web content, and performing computation. Canisters run on a network of independent data centers, distributed globally, coordinated through cryptographic consensus. Unlike most blockchains, ICP separates consensus from execution through a system of subnets. Each subnet operates as its own blockchain, capable of scaling computation horizontally. This design allows Internet Computer to increase capacity by adding more subnets rather than overloading a single chain. Chain key cryptography enables these subnets to function as one unified network. It allows ICP to finalize transactions quickly and interact with other blockchains without relying on traditional bridges. By 2026, Internet Computer hosts a growing number of fully on-chain applications. These include decentralized social networks, developer tools, governance platforms, and data services. Unlike decentralized apps on most blockchains, ICP applications do not rely on centralized front ends. Websites hosted on ICP are served directly from the blockchain. This means there is no external hosting provider that can censor content, shut down servers, or collect user data. Identity systems on ICP use cryptographic authentication rather than usernames and passwords, reducing reliance on centralized identity providers. This capability remains rare across crypto. Most Web3 applications still depend heavily on Web2 infrastructure for hosting, storage, and delivery. ICP's model replaces traditional gas fees with a reverse gas system. Developers prepay for computation and storage using cycles, which are converted from ICP tokens. Users interact with applications without paying transaction fees directly, making the user experience closer to traditional web services. This design shifts cost responsibility to developers, similar to how companies pay for cloud services today. It also enables predictable costs for applications, which is critical for building consumer-facing platforms. By January 2026, ICP supports persistent storage and continuous computation at scale. This allows applications to maintain state over time without external databases, a feature that remains limited or expensive on other blockchains. Developer adoption on Internet Computer has grown steadily but remains niche. The learning curve is steeper than for traditional smart contract platforms. Developers must understand canisters, subnet architecture, and ICP's programming models, which differ from Solidity-based environments. Tooling improved significantly through 2024 and 2025. SDKs matured, documentation expanded. Language support broadened beyond Motoko to include Rust and other ecosystems. This lowered barriers to entry, though onboarding remains more complex than deploying simple smart contracts. ICP attracts developers interested in building full-stack, decentralized applications rather than financial primitives alone. Usage on Internet Computer differs from typical DeFi-centric networks. Transaction counts are less relevant than application interactions. Metrics focus on active canisters, data storage, and user engagement with hosted services. By 2026, several applications on ICP support thousands to millions of users, particularly in decentralized social media, DAO tooling, and developer platforms. These applications demonstrate that fully on-chain services can function at real-world scale. However, ICP remains underrepresented in speculative sectors such as meme coins or high-frequency trading, which dominate activity on other chains. A growing focus for Internet Computer is decentralized AI and compute. ICP's architecture allows machine learning models and inference to run directly on-chain without centralized servers. This enables verifiable AI execution, where outputs can be audited and reproduced. As concerns around centralized AI infrastructure grow, ICP's ability to host compute-heavy workloads without cloud providers becomes increasingly relevant. By January 2026, multiple projects experiment with decentralized AI services on ICP, though the space remains early. This positioning aligns ICP with long-term infrastructure narratives rather than short-term speculation. ICP's token plays multiple roles. It is used for governance, staking, and converting into cycles to power computation. Token holders can lock ICP to participate in network governance through the network nervous system, which manages upgrades and economic parameters. The initial supply and early distribution of ICP shaped negative perception during prior cycles. By 2026, inflation and rewards follow predictable schedules, and token utility is better understood within the ecosystem. ICP's valuation is tied less to transaction fees and more to compute demand and governance participation. Internet Computer launched into a market that was unprepared to evaluate infrastructure complexity. Expectations focused on price rather than functionality. When speculative momentum faded, technical progress continued largely unnoticed. The project's messaging struggled to communicate its value clearly to retail investors. Its use cases did not align neatly with narratives driving prior cycles, such as DeFi yields or NFT speculation. By the time real applications matured, attention had shifted elsewhere. By January 2026, the question is no longer whether ICP works. It does. The question is whether the market is ready to value decentralized cloud infrastructure. As Web3 matures, reliance on centralized hosting becomes a growing risk. Regulatory pressure, censorship, and infrastructure consolidation highlight weaknesses in today's internet stack. ICP's vision addresses these issues directly, but adoption requires a shift in priorities. ICP's complexity may be a barrier in speculative markets, but an advantage in infrastructure-driven phases. Internet Computer does not compete on simplicity or hype. It competes on capability. It offers something few blockchains attempt: a fully decentralized alternative to the modern internet stack. By 2026, ICP stands as one of the clearest attempts to merge blockchain, cloud compute, and web services into a single system. Whether that vision becomes mainstream remains uncertain. ICP's future depends on whether decentralized compute becomes essential rather than optional. If Web3 applications demand censorship resistance, verifiable compute, and independence from centralized cloud providers, ICP's architecture becomes increasingly relevant. In 2026, Internet Computer is no longer about hype cycles. It is about whether the next phase of the internet requires the tools it has been quietly building. Subscribe to the Crypto IQ, as we will come back again with another interesting topic.